Right. Oh, oopsie daisy. Hello, hello. How's it going? Hope you guys are doing fine. Let's pause chat here. Let's make Yash co-host. Let me start recording and answer a few questions here. All right. Questions include are data accounts created for every contract deployed by the same program account? Are for every contract deployed by the same program account? What does that mean? Contract deployed by a program account. There are associated data accounts. There are two ways you can create data accounts, PDAs or non-PDAs. Either way, if you create a PDA or a non-PDA, both of these accounts are owned by that program. But like a program account doesn't create other program accounts, which I'm getting from your question. Maybe elaborate your question a little bit. Let me see this here. This is actually a more convincing screen. Let me just stream from here. All right, hello. Any good resource to build AI apps? What do you mean AI apps? I don't think there are any good resources for that just yet. I'm assuming by AI apps you mean GPT wrappers or something. Very first principles, to build them. I don't know a resource as such. All righty, 1 second. Cool. Start recording. Projects using WebRTC. I'll probably make one on YouTube. I'm thinking I have an idea recently, like 5 minutes ago that came that will require WebRTC. So might add that. Anything else before we get into today's video? Sabchanga C. Cool. All right, we'll get right into it then. I'll share my smaller screen this time. There we go. Cool. Today we're going to revise a little bit about Prometheus and then get into Grafana. Both of them interesting technologies. Today, surprisingly, in the morning, I was adding Prometheus to a Kubernetes cluster that I have. So I don't know if you remember from last week, but last week we discussed there are a few ways to add Prometheus to your application. There's the push gateway, there is the standard pull method, and then there is service discovery. That was what I was doing this morning. If you want to check what I was doing, you should look at this repo and the comments that I made this morning. So it'll be interesting when we reach Kubernetes and try to do this there. Right now, like today, we'll do the simple bits, which includes monitoring a simple Node.js application and then creating graphs on top of it, not just in Prometheus UI, but also in Grafana. So a quick recap from last week. Last week, we revised a little bit about what is monitoring, basically creating dashboards like these on top of your application. So you can track the CPU usage, the memory usage, the storage usage, the logs of your application in a centralized dashboard. If things go down, this is the dashboard that you look at. Then we understood Prometheus and its architecture. So very quick recap. Prometheus it's essentially a time series database, which means a database that tracks events over time. Until now, we haven't really dealt too much with time series databases. We have simple CRUD applications. We have a to-do database. We're not tracking something every 15 seconds or every 20 seconds. What is a good example of tracking something every 15 seconds? CPU usage, memory usage, storage, even trading graphs like these that we discussed last week. Okay, all the graphs that you might see in a trading application, this is also stored in a time series database because we need to store between this time and this time, what was the lowest price, what was the highest price. Between this time and this time, what was the lowest price and the highest price, which means even if there is zero activity, even if no buys and sells happen, even if the price of a asset remains constant, you still store empty wicks. You still store empty sort of ticks in your database. You keep tracking your metrics or whatever you are tracking every 15 seconds, 10 seconds, 20 seconds, whatever that metric is. Prometheus is just that. It's a time series database that scrapes metrics from your backend. So if you look at this architecture, this is Prometheus. We did not start Prometheus last week. Last week, we just built this much, a Node.js application, standard Node.js application, to-do application. But we did one extra thing. We exposed the metrics, some custom metrics from our Node.js application. There were 3 types of metrics: counter, gauges, and histograms. Counter and gauges being the easy bits, histogram being slightly harder. We exported the metrics from our Node.js application. And today we're going to start Prometheus and start to pull those metrics from here. We'll start to visualize those metrics in Prometheus UI. Ignore this and this for now. This is what I was doing this morning. This is another thing you might have to do if you're ever creating short-lived applications. Even this uses the push gateway under the hood. If you ever want to, in the future, deploy Prometheus inside your Kubernetes cluster where pods are going up and down very quickly, or if you have an auto-scaling group where machines are going up and down very quickly, you use the push gateway. You don't use this standard method that we're using today. The method that we're using today sort of assumes okay, this is a long-running application. Your EC2 machine, a single VM you have that is going to run for 20 hours, 30 hours, 5 days, 15 days, 1 year, and Prometheus will have that machine as a target and it will scrape metrics from them. If you have a fleet of servers that are going up and down, then pulling metrics isn't the best idea. You need to push metrics from your application. That's a whole different thing we're not discussing today. So last week, we did not create anything related to Prometheus. We just exposed the metrics from our Node.js application on an endpoint called /metrics. What were the stats that we were exposing? The total time it took for a request to get handled, the number of requests that are coming on a specific endpoint, the total number of active requests that are present. So these were a few metrics that we sort of exposed in our Node.js application last week. Let's explore the Node.js application very quickly. Let's go through the slides first. This was a simple Node.js application. As you can see, it does nothing. It has a /user endpoint that returns the user's a simple object, a post /user endpoint that again just returns the user a random thing, like basically nothing, both dummy endpoints, and a middleware that would just track the start time, call the next function, the end time, and log this on the screen. So by the end of it, when we were running our application and visiting the application in our browser, we were seeing these logs. Okay, request took 10 milliseconds to get handled. Request took 2 milliseconds to get handled. We were just logging metrics, no Prometheus, nothing else, a simple middleware that was applied throughout our application by using app.use middleware. Whenever a request comes, track the start time, call next, that will actually call the function, the actual handler or the next handler in the express request handler chain, end time, and then log it. This is the dumbest way to do monitoring. You are seeing all the logs. You can track ke, request took 10 milliseconds, 2 milliseconds, 1 milliseconds. Problem is, you can't create dashboards on top of it. You can't put up alerts. If one of the logs says request took 20,000 milliseconds, that means something is wrong and you need to debug it. You can't do that here. For that, we added Prometheus /metrics using Prometheus. There are 3 types of metrics in Prometheus. Counter, something that always goes up. For example, the number of requests that you sent to your backend. The number of requests sent to your backend will always go up. It will never go down. Fair, right? Number of requests will always increase, and hence we create a counter for it. A gauge, something that can increase also and decrease also over time. For example, CPU usage on a machine that can go up, that can also go down. It can reach 50%. It can come down to 20%, go down to 10%. So if there is a metric that can go up and down, you create a gauge for it. If there is a metric that only goes up, you create a counter for it. Third was histogram. A histogram, slightly more complicated, but some things don't just go up by 1 or go down by 1. Some things aren't really incremental in nature. For example, the request time. The time it took for a request to get handled could be 1 millisecond, could be 100 milliseconds, could be 1000 milliseconds. It's very sporadic. It's never a constant number. Number of requests always go up by 1. 1 request came, 2 requests came, 3 requests came. CPU usage also, you can argue, is going to be limited to 1%, 2%, 20%, 100%. It'll be a number between 0 and 100. Histograms are used for tracking metrics that could be anything, have an infinite space of what they can be. They can be 2 milliseconds, 100 milliseconds, 1000 milliseconds. These are the 3 important sort of metrics that you can track. We created the very first metric. We created a counter. We structured our application a little bit better. We created a gauge, structured our application a little bit better. We created histograms. Histograms were a little difficult to digest, but by the end, everyone was able to understand them. I think some 90%. What were histograms? ये थोड़ा सा discuss कर लेते हैं. In the end, we want to track a few things. We want to track, let's say, the request time, number of requests, and number of pending /active requests. Let's say these are the 3 things we want to track on our Express server. We have an Express server in which a lot of users are going to send a lot of requests. It's a very active Express server. Your application is doing great. And hence, I want to track the total number of requests, which in this case will be how much? Let's say only 3 requests have come. So that number would be 3. The number of active/pending requests. Most of the requests will get back a response in like 2 milliseconds, 5 milliseconds, 100 milliseconds. But let's say you have an extremely active application. There are a million users hitting it. So what might happen is कि 3 have been responded, 3 are still active, which means कि अभी इनको response गया नहीं है. Your server is still computing something, talking to a database. So the number of pending/active requests represents that. How many requests have come to the Express server and not yet been responded with. This number will usually be really high. After 1 year of running your application, this might reach 10 million. Number of pending requests will always remain the same, like somewhere around, let's say 10 or 100. In this case, it will be 4 because 4 requests have come and abhi unko respond nahi kiya hai humne. Of course, after 10 milliseconds, this might get responded back. And then this number might go down to 3. After 20 milliseconds, this might get back a response. Then this number will go back to 2, so on and so forth. This is going to be a counter, ever increasing. This is going to be a gauge, can increase, can decrease. Request time is a tricky one. Amongst these many requests that have come, the first request might have taken, let's say 100 milliseconds to get a response. Second might have taken 10 milliseconds. Third might have taken 12 milliseconds. Fourth might have taken 200 milliseconds. Fifth might have taken 230 milliseconds. So the number is it's a lot. Like it can be anything. So you can't really store, if you have to store number of requests, how will you store it? Here, number of requests equal to 3. How will you store the number of active requests? Number of active requests, 3. How will you store the response times? Will you store it like this? Number of requests that took 100 milliseconds, 1. Number of requests that took 10 milliseconds, 1. Number of requests that took 200 milliseconds, 1. So on and so forth. Will you create a new row for every response time? The answer is no. You'll have infinite number of rows. Your database will become very big if you are tracking each and every response time. In the real world, you never care about how many people got their response in 1 milliseconds. 100 milliseconds. How many people got it in 10 milliseconds? How many people got it in 200 milliseconds? You don't care about that. You care about how many people got their response in between 0 and 100 milliseconds. How many got it in between 100 and 250 milliseconds? How many got it in between 250 to 1000 milliseconds? So you can break your application down into buckets. What can you break it down into? Into buckets. And that is what a histogram provides you. Okay, you break the number that you're tracking into buckets. This is a number of requests. Number of requests that took between 0 and 100 milliseconds. 1, let's say. वैसे कितना है number? 1, 2. 2 is the number. 2, this one. And this one took between 0 and 100 milliseconds. 100 and 250 के बीच में, this and this. 3 requests took between 100 and 250 milliseconds and 0 requests took between 250 and 1000 milliseconds. What have we done? We have broken our third metric, request time, into a histogram. Something like this. Okay, the number of requests that took between 0 to 100 milliseconds is this much. Number of requests that took between 100 to 250 is this much. And number of requests that took greater than 250 is this much. Whenever you want to track something like this, you use histograms, because otherwise you'll have an infinite amount of things that you'll be storing in your database. इसका भी code पढ़ेंगे. We'll read through the code very quickly. But there was one peculiar thing about histograms, which was that they are always additive. You don't store कि 0 से 100 के बीच में कितनी है, 100 से 250 के बीच में कितनी है, greater than 250 कितनी है. You don't store that. You store how many are between 0 and 100. Let's say there were 2. How many are between 0 and 250? Let's say that will be these 2 and 3 more. So that number will be 5. And the third thing that you store is how many are between 0 to, let's say, 2500, which will again be 5 because increase nahi huya between this and this. They are always additive in nature. Whenever you create a histogram, you track less than 100 wali kitni hai, less than 250 wali kitni hai, less than 2500 wali kitni hai. You don't track between 0 and 200, between 100 and 250, between 250 and 2500. You don't track this. You track How many are less than 100? How many are less than 250? How many are less than 2500? You can always calculate the diff, right? If I ask you how many took between 250 milliseconds and 2500 milliseconds, it's just this minus this, which is 0. How many took between 100 and 250 milliseconds? It's just this minus this, which is 3. So whenever you're tracking histograms, they're additive in nature. When do you track histograms? Whenever there is something highly dynamic in nature and you don't care about the exact values. You don't care how many people got 3 millisecond response time. You care about how many got less than 100. Those are good users of ours, or users who got good responses. How many took between 100 and 250? That's 3. Those are users that got decentish response. How many took between 250 and 2500? 0 in our case, so we have a decent application. These are the 3 types of metrics that you track. And last week, we wrote all the code to track these for an Express application. This is the final code from last week. So let's clone this repository locally, because only after we clone this repository are we going to add some more code to it and add Grafana on top of Prometheus. So the next step is cloning this repository locally and adding monitoring to it, adding a few things. So this is mostly finished. We're just running and exploring a few things. But clone the repo locally, try to run it throughout today. So let me clone. Let me open it in Cursor or Visual Studio Code, whichever one you want. Let's explore it's a simple Express application. Let's explore source/index.ts. Let me do a npm install. So all the red squigglies go away. We say import Express, import some middleware. We'll see what that middleware is. Import client from prom client. What is prom client or Prometheus client? It's a JavaScript library that helps you expose metrics. Very soon we are going to create these metrics, track these metrics. You need to expose these metrics on an endpoint. If you remember from last week, in the end, we expose all of our metrics on an endpoint that looks like this, your website/metrics. This is a specific format you expose your metrics in, and Prometheus client sort of creates that metrics endpoint, exposes all of your metrics in that specific format. So import client from prom client, and then a middleware will come to what this middleware is, or metrics middleware is. I've added 1, 2, 3 endpoints. The first endpoint, whenever someone hits the /user endpoint, we wait for like 1 second and then respond back. We should change this. Let's change this to math.random into 1000, or let's say 2500. We wait for a random time anywhere between 0 and 2500 milliseconds. So either 0 to 2.5 seconds. We wait for this much time, and only then we respond back to the user. That's the first endpoint, simple enough. Second endpoint, simple enough. Third is the interesting endpoint. Whenever the user hits /metrics, we get the metrics from this client, this Prometheus client. We return those metrics to the user. This line of code just changes the content type of the result. Content type could be HTML, could be simple text, could be JSON. Whatever is the content type for metrics is what gets returned. And more importantly, rest.end metrics sends all of these metrics in the response. So this response, this endpoint is actually controlled by the prom client library. The question is, where have I defined my metrics? I have not created a counter over here. I have not created a gauge over here. I have not created a histogram over here. Where have I done all of that? And the answer is in these middlewares. If you notice, I am using this middleware and this metrics middleware throughout my application. App.use middleware kya karta hai? It applies this middleware to all of these endpoints, and hence all these endpoints, before the control reaches here, it actually first goes to this middleware, then goes to this middleware, then reaches the respective endpoint. So probably all the tracking is happening here. We want to track the number of requests. So if there is a middleware, it can capture every request, right? It can capture every request, increase the counter. We want to track the number of active users. So whenever a request comes, we can track how the request has come, increase the number of active users. Whenever the request ends, we can decrease the number of active users. The third thing we want to track is the request time. So again, somewhere in this middleware, let's open the first middleware. What does it do? It just, the first middleware is faddy. Don't worry about the first middleware, it does nothing. Second middleware, feel free to also remove the first middleware. The metrics middleware, if you look at, it does a few things, nothing too complicated. Const start time equal to date not now. It tracks the current time. जब भी पहली request आएगी, whenever a request comes here, it will first go to this middleware. It will track the start time. It will increase the number of active requests. So what is this? Active requests gauge dot increase. Question is, what is active requests gauge, Harkirat? You notice it's defined in a separate file, and it's simply defined as import client from prom client. Export const active request gauge equal to new client dot gauge, the name of the gauge, and some helper text for it. That's it. That's how you define a gauge. That's how you use a gauge. Increment whenever the request comes, decrement whenever the request succeeds. So what have we written? Whenever the request comes, increase kar do gauge ko. Let's say after 20 seconds the request responds back. Then this rest.onFinish callback will get called, and we will decrease the endpoint. The express library का जो response object है, उस पे you can register an onFinish event handler or an onFinish callback. Okay, whenever the response gets handled, whenever something is returned, whenever the actual endpoint will respond back with something, this callback will get called. इसके अंदर we do the rest of the things. We decrease the gauge. We increase the counter. Okay, the number of requests handled have increased now. Notice this is a little different. Rec counter dot increase, and I send a few things inside. When I increase the gauge, I did not send any arguments. Whenever I decrease the gauge, I did not send any argument. When I am increasing the request counter, जो हमेशा बढ़ती रहेगी, 3 metrics थे ना हमारे पास. We had 3 metrics. Request time, we'll get to that in the end. Number of requests, जब मैं increase कर रहा हूं, when I'm increasing the number of requests, I'm giving it some things as arguments here. We'll see what that is. And then the third one is the histogram. अब ये हमने last week किया था, तो is this already clear कि what all three of these are doing? Let's do a poll very soon. But we have discussed this completely last week. When you start this application, npm run start, npm install, you might have to do a npm install TypeScript and then do a npm run start. It says I'm already running something on port 3000. Let me do it again. npm run start. And now if I go to localhost 3000 /user, I hit the user endpoint. Let me hit it a few times. Notice it responds back, with a delay of anywhere between 0 to 2500 milliseconds. And then there is the metrics endpoint where all the metrics are being exposed. Hope it's a little overwhelming for the people seeing this for the first time. For the people who came last week, this is very easy. But in Prometheus, the thing that we did last week was, how do you expose metrics from your application? 3 types of metrics: a gauge, active requests that can go up and down, total number of requests, which is a counter. But notice every request पे we can add some labels. हमने कुछ labels डाले हैं कि यार total number of requests with the method get on the route slash that returned a status code of 404 R2. Total number of requests with the method get on the route slash user that returned a status code of 304 is 3. And then you can add more and more requests here. Let me hit a random endpoint. Something like this. And /user/1. I'm hitting random endpoints that don't exist. Whenever I hit these endpoints, inki request count is being calculated and dumped on this metrics endpoint. Here, this /user/1/1 was hit 8 times. This /user/1 was hit 1 time. So on and so forth. In the end, you'll have limited number of endpoints, right? So that list of endpoints and how many times they were hit will be tracked here. Only thing is, we are not simply tracking kitni requests आई. We are adding some more dimensions to it. We are tracking kitni requests आई with the method get on this endpoint with which return the status code. There might be another row below it which has the same method, has the same route, but a different status code. Let's say some users see 200 on the slash endpoint, some users see 404 on the slash endpoint. All of those will be tracked over here. These are the counters. This is the gauge. And these are the histogram data. Let's try to read through the histogram data for people who are seeing this for the first time. What it says is कि the total request duration कितनी देर लगी इसको respond back करने में with the method get on this route with this status code 400 less than equal to 0.1 milliseconds. कितनी requests थी जो less than 0.1 milliseconds में handle हुई? 0. How many requests to the get endpoint on the slash route with the code 404 that were less than 5 milliseconds or equal to 5 milliseconds? 2. How many requests were less than 50? 2. 50, 2. 100, 2. 300, 2. So all of our requests got handled greater than 0.1 milliseconds में, less than 5 milliseconds में. 0 requests got handled greater than 5 milliseconds में, less than 15 milliseconds में. This histogram that I had created, number of requests that got handled in less than 100 seconds, 2. Number of requests that got handled in less than 250 milliseconds, 5. This is how they look like on our final slash metrics endpoint. The number of requests with some labels, with some dimensions. Here, get requests with a slash route with code 404, जो less than equal to 0.1 millisecond li are 0, 5 less than equal to 5 li are 2, less than equal to 15 li are 2, less than equal to infinity li are 2. So you can clearly, this is probably a better example. Okay, the number of requests that got handled with the get endpoint on the slash user endpoint with the get method that returned a 304 status code are 0000 and then 2 पहली बार आया. मतलब 2 requests took between 100 and 300 milliseconds. 0 requests took between 300 and 500 because less than 500 वाली भी 2 है, less than 300 वाली भी 2 है, which means 300 से पहले 2 handle हुई, 500 से पहले 2 handle हुई, which means ये 500 से पहले handle हुई वो 300 से पहले वाली ही है. And hence between 300 and 500 0 got handled. Between 500 and 1000 1 got handled. That's why it got increased from 2 to 3. Between 1000 and 3000 1 got handled. None got handled between greater than 3000. None took greater than 3000 milliseconds. ये चीज clear है? 8:30 हो गए हैं. This was just a recap from last week. If this is not clear, we have a video about this last week, but let's do a poll and just see where everyone is at. Do we remember this part of the architecture from last week? The part where you create a Node.js application that exposes some endpoints. Okay, this is clear. 88% is decent. Today, so what have we done? We have done this, a Node.js application that exposes metrics. Ab kal ko, if you write a Golang application, there will be a Prometheus client over there. Use it to create counters, increase counters, expose it on a slash metrics endpoint. The final endpoint will look the same, irrespective of if you are creating a Golang application, a Rust application, or a Node.js application. This is the format in which Prometheus expects data to be present. We have created this. Today, we're going to create this. We're going to start Prometheus. We're going to tell Prometheus, this is your target. This is where you're supposed to pull data from. And we'll tell Prometheus a scrape interval. Every 20 seconds pull from here, or every 100 milliseconds pull from here, or every 2 minutes pull from here. And that is it. Prometheus is just tracking your metrics. It is not helping you visualize them. Uske liye we will use Prometheus UI. We'll come to the UI very soon. So let's fast forward to actually starting Prometheus, which is this slide right here. We are done with this. We are going to do this in this section. Until now, we have exposed a slash metrics endpoint, but no one is scraping using that endpoint. Prometheus hasn't started and isn't maintaining a time series data of all the metrics. Prometheus actually scrapes these metrics so you can visualize them over time. It scrapes them every 20 seconds, 30 seconds, whatever your interval is. For that, you need to start Prometheus and give it a source of the metrics. To do that, आपको उसको बताना होगा कहां से pull करना है. So let's create a prometheus.yaml file. I think it might already exist. If you look at the code, you'll find a prometheus.yaml file. And you might be tempted to do this. Here, my prometheus.yaml looks like this. The scrape interval is every 15 seconds. Every 15 seconds, I want to scrape. Every 15 seconds, I want to pull metrics from here. And these are the jobs that I'm tracking. These are the servers that I'm tracking. In the future, you might have multiple servers. You might deploy this in 5 different machines. But today, let's say we're deploying it on a single machine. So in that case, you specify kahan se isko scrape karna hai. By default, the endpoint is /metrics. So it will start to pull from the /metrics endpoint. And the name of our application, give it whatever name you want. Node.js application, call it user application, whatever you feel. This config is enough for us to start Prometheus now. How should we start Prometheus? Should we start it using natively? No, we should start it using Docker because it's just easy to start anything locally using Docker. So you might be tempted to do this. Let's do this and see what's the problem here. Here is a Docker command for running Prometheus locally. Let me keep the Node.js application running on one terminal. Let me start Prometheus in another terminal. Docker run with this port mapping 9090:9090, which means whatever is running on port 9090 here gets exposed on my Mac machine. We understand port mapping by. A new thing I've added here is a bind mount. I am mounting the ./prometheus.yaml file, which is this file right here, inside the Docker container on /etc/prometheus/prometheus.yaml. I want कि जो Docker container है उसके अंदर भी ये file present हो, right? Prometheus.yaml is right now on my local Mac machine. It will not exist in the container unless one easy way for me to put it in the container is to add a volume mount, or more technically what's called a bind mount, which basically says कि ये file जो मेरी machine में present है, this file that's present on ./prometheus.yaml is mounted inside the Docker container at this path, which is the default path where you're supposed to put the Prometheus configuration file. And then this is the name of the image, prom/Prometheus. You might be tempted to do this and press enter. But what will be the problem? Can you already predict? इस configuration में क्या गलती है? अभी क्या हो रहा है? What is happening right now? This is my Mac machine. I am running natively a Node.js application that is exposed on port 3000 on my machine. This is running natively, not inside a Docker container. And now I am starting a Docker container, which is running Prometheus, which is also exposing Prometheus on port 9090 using a port mapping. And it is trying to scrape from localhost :3000. Is it trying to scrape from here, or is it trying to scrape from here? Localhost :3000. For the container, the Docker container is its own network, right? Localhost inside the Docker container means what? It means mera port 3000. That's why port mappings were introduced. It's very hard for Docker containers to talk to the Mac machine like this. A Docker container, if you write localhost :3000, it will start to find the node application on the port 3000 on that Docker container. It will not start to find it on the Mac machine. So Prometheus.yaml जो यहाँ present है, the Prometheus.yaml that is actually present on my machine. There is a Prometheus.yaml that's present on my machine that I have mounted inside this Docker container. So it exists here as well. इसमें I have written localhost :3000 as the target. But that means a process running on 3000 on this container. There is nothing running on 3000 on this container. It is running outside. It is running here on the Mac machine. So how can I let Prometheus that is running inside a Docker container talk to a Node.js application that is running outside? Can you somehow punch out of the Docker container and talk to the host machine? There are ways, but no easy ways. So what can we do? What is the other thing we can do? Can we containerize the Node.js application also? can we somehow containerize the Node.js application and connect both of these through a Docker network? थोड़ा complicated सा हो गया ये. Let me remove this. What if I containerize the Node.js application as well? Expose it on 3000 on the host machine, that is fine. But the bigger thing is I connect with them via a Docker network. I connect them via a Docker network so they can talk to each other. Prometheus can identify and find the Node.js process. Node.js can also find Prometheus even though it doesn't need to. But if we start two Docker containers in the same network, they can discover each other, they can talk to each other. We have done this in the past when we were creating a Node.js application. We're trying to containerize a Node.js application that was supposed to talk to MongoDB. So when we were discussing networks in Docker, this is exactly what we discussed. Okay, two containers can talk to each other, but a container can't really talk outside. A Node.js application, so yahan pe, the Node.js application on a host machine can talk to something inside a Docker container, but the Docker container can't talk to something running on the host machine, which is why it's just a good idea to run both of them directly inside Docker on the same network. So if you try this and press enter, Prometheus will start on localhost colon 9090. You can go to localhost colon 9090 and hope to see some data. We'll explore this whole dashboard. But if you will click on status and click on targets, you'll notice it says unknown. Iska status nahi pata mujhe. There is a target, localhost colon 3000 / metrics. But I don't know what its status is. Why? Because Prometheus is running inside Docker. Node.js is running on the host machine. So localhost colon 3000 means this port right here. It can't find anything over here. And hence, what can we do? You can do a few things. Like you can start Prometheus natively on your machine. That also works. If you start Prometheus directly on your machine, don't use Docker. Tab bhi kaam chal jayega. But what is the other thing you can do? You can start both the Docker containers and connect them via a network. You can containerize your Node.js application. Very simple to do. We have done it many times. From node 20, add a working directory, copy our package.json, do an npm install, copy the rest of the files, expose port 3000, run npm run start. That's how you containerize a very simple Node.js application. This we have done in the Docker ka class. So if this is containerized, can't I start my Node.js application inside Docker, connected to a network? I can start Prometheus also connected to a network, and then they can both find each other. How can I do it? I can either do like this. Docker network create prom network. I can create a new Docker network. Then I can first start my Node.js application, Docker run -p node-app 3000 colon 3000 and -- network equal to prom_network. I can do this. And then I can start Prometheus as well. So same thing, but make sure you're connecting it to the prom network that we had created. So we can run these three commands. And then this guy will be able to find this guy on its name, node-app. Yahan pe, in prometheus.config, I should not write localhost colon 3000. I should write whatever the name of the container is, which is node-app in our case. Sorry, not this. I have to actually give it a name. When I'm starting it, I have to give it a name. -- name equal to node-app. And then using this name, one Docker container can find other Docker container. So Prometheus can identify the other Docker container ka port 3000 on node-app. Basically, node-app is just a domain name now, similar to google.com. Just like google.com is a domain name, localhost is a domain name that points to this. Google.com is a domain name that points to some IP. Similarly, node-app will become a domain name of sorts that will point to some internal IP that will lead you to this Docker container. So you can either do this or you can create a Docker compose file. When you create a Docker compose file, all the things that you are starting get connected via a default network. Docker compose, we remember, if you want to start multiple containers together, which is something we want today, we want to start the Node.js application. We want to start Prometheus. And eventually we will want to start Grafana. Abhi isko ignore karo. Don't worry about the third section. We want to start the Node.js application Prometheus. We want to connect them via a network. So you can explicitly add a network. Even if you don't add a network explicitly, they automatically get connected by a network. They can identify each other or find each other using the name of the application, which in this case is node-app. That is why in Prometheus.yaml, originally I was using node-app over here, because Prometheus will be able to find the Node.js process on node app :3000. Node app will become the IP of the other container, because all three of these containers are connected via a network. So if you try to look at the Docker Compose file, node app is simple. It's not an image that exists somewhere. You have to build it in the current folder, which means the Docker file of this is in the current folder. This is the port mapping, and this is the network that we are attaching it to. Prometheus, it exists on Docker Hub. I don't have it locally. It's not my own code base. It's someone else's code base. Someone smart has written. So this is the image that I need to pull. This is the volume mounts that we just added before also. This is a little too much. You can also just do this Prometheus.yaml/Prometheus.yaml. We are mounting the whole folder. We don't need to mount the whole folder. Just that file is good enough. Port mapping and networks. What this will do is, when I start this Docker Compose file, it will start a node app server. It will start Prometheus, and Prometheus the Prometheus.yaml file will be mounted. Notice /etc/Prometheus pe the current folder is mounted. Matlab /etc/Prometheus will contain all of these files. That's a little too much. We don't want this to contain all the files. We want this folder to contain just ./Prometheus.yaml, which is why you can write this as well. Or you can just mount the whole folder, either is fine. Isme targets is node-app :3000. It isn't localhost :3000, because localhost is still that container ka network. Node-app is the network, is the domain name inside this, which points to the IP of the other container, because they are connected by the same network. If they were not connected by the same network, वैसे तो Docker Compose में whatever you write are connected by a default network, but let's say that isn't the case, then this networks monitoring is what is connecting both of them, is what is leading to this guy being able to identify this guy, and this guy can also identify this guy. It doesn't need to. Node.js application doesn't need to talk to the Prometheus process. Prometheus needs to talk to the Node.js process, and it is doing that on this domain and on this port. How do you start a Docker Compose file locally? Docker-compose up. What does it say? Something is already running on port 3000. So let me stop the thing running on port 3000. Docker Compose up. It starts 3 containers. Grafana we'll come to eventually. This is a technology we haven't discussed yet. Node.js application, Prometheus, both of these have started. You see logs from the Node.js application. You see logs from Prometheus. And the best part now is, if I do go to localhost :9090, we added a port mapping, right? On my host machine, port 9090 will point to the port 9090 of the Prometheus container. So that is why I can access it. And if I now go to targets, even though it says node app :3000/metrics, it is still up. Why? This is a very weird domain name. It isn't google.com/metrics. It isn't localhost/metrics. It's node app/metrics. It works because node app indeed points to a specific domain name or a specific IP, the IP of this other process. And that is how Prometheus is now able to scrape every 15 seconds. That is our scrape interval, right? Our scrape interval was every 15 seconds, which means every 15 seconds now, the Prometheus process is scraping metrics from here. If I go to localhost :3000/user and hit it a few times, and now if I go to /metrics, you will see active requests 3, because this request was active, this request was active, and this request was active. You will see total number of get requests are 5 on the /metrics endpoint. Notice it's 5. I have only hit this once. Why is it 5? Because Prometheus is constantly scraping it every 15 seconds. How many times did I hit the /metrics endpoint? I mean, this is the first time I'm coming here. The reason this number is 5 is because 4 times Prometheus had scraped this. If I refresh again, it should go up to 6. अभी तक number of requests are 5 on the slash metrics endpoint. If I refresh, it should go up to 6, but it went up to 8. Why? Because Prometheus is now constantly polling the metrics endpoint and storing the data in a time series format. Now you can start to query the data in a slightly cleaner fashion. Abhi ke liye, you can still sort of look at data, but you can't look at time series data. You can look at total number of requests. You can't look at total number of requests a few minutes ago. You can look at active requests. You can't look at active requests 5 minutes ago. All of that data is now being scraped and stored over here. So yahan pe, if I try to query active underscore requests, it gives me the same thing. Kya active requests abhi to 2 hai. Currently, active requests points to 2. But if I click on graph, it shows me active requests over time. Isko ignore kar do, ye mera pehle ka data hai. Abhi ke liye, it shows you this. Ke number of active requests were 1 initially, have gone down to 2. Now it will again go back to 1 because I have no active requests open over here. And that's how you can track the simplest thing right now, active requests. You can see it in a time series format, which is sort of what you want, right? You want graphs for all of these metrics that you have exposed. So do we understand this? Do we understand how to start Prometheus? How to give it a target to poll metrics from or get metrics from? And how to ensure that you can start those in a Docker container. And how can you start Prometheus in a Docker container and not worry about whatever, one being able to discover the other. Do we understand everything I covered in this few minutes? Let's do a poll. Already simple enough. 84%. I'll look at Q&A for 2 minutes. Then I'll proceed to, we'll just create some graphs and go from there. How do you know Docker Compose में सब commands लिखी हैं? How to know Docker Compose में ये सब commands लिखी हैं? मैंने खुद से लिखी है. I wrote them myself. But network name typo. Where was it? See, there was a typo somewhere. But show the metrics. I don't think we're tracking any metrics there. I did something this morning that I can show, but I don't have any metrics for advantage.com. Why can't we run Prometheus locally? You don't need container. It's just easy to do it. You can run it locally, and in that case, it's fine. Any other questions? Run the node app on Docker, exactly what we did. A few questions from before. A code base recap and push it. It's already pushed. So you can, I haven't changed anything. Is Prometheus distributed? It isn't. You can't scale it horizontally. Docs link and code link can be shared by Yash today in the chat. And Google Analytics does the same thing. We don't know the architecture of how Google Analytics does it, but it lets you do something similar, which is, yes, it lets you track metrics. What if someone reaches my server on the slash metrics endpoint and gets my app metrics? How can we secure it? That's a great question. Who will answer? How can we make sure this endpoint is protected? The answer is simple, right? Just add a simple auth check. Onst header equal to rec dot headers dot authorization, and then if header is not equal to whatever super secret header, then just return unauthorized. And in your Prometheus.yaml, you can specify what headers to send along. So वो साथ में headers भेज देगा. So Prometheus will be able to pull the data, but if someone else tries to hit it, then they will reach this if condition and they'll get returned right there. Okay? Good question. Isn't the same like in server internal calls? What is the same like server internal calls? What if I'm using AWS managed Prometheus? How will my server detect? You probably have your application hosted on AWS or out on the world. So, you can give it, when you run this in production, then to yahan pe in Prometheus.yaml, you'll have simple, right? App or api.handexdevs.com. You'll have another target called, let's say, api2.handexdevs.com, so on and so forth. So the targets are pretty clear. When you're running it locally, it gets a little complicated. When you're running it on the internet, pretty simple. What is Trino? I have no idea. First time hearing about it. Recap how to set up Prometheus UI. It's simple. Just do Docker Compose up and khatam. Docker-compose up will start everything locally for you. Just get the code base and start it. You can also put it behind. You can do whatever you want. You can put various types of passwords using Nginx or something else, or like a header check that added a simple one. But in the end, you need to tell Prometheus those things. Prometheus needs to send those headers. So at least Prometheus is allowed to hit that endpoint. No one on the internet should be allowed, but Prometheus should be allowed, right? So whatever auth checks you're adding, you have to specify over here how Prometheus should hit your endpoint so that at least it gets access. For microservices, do we need to integrate Prometheus for each service independently, and how does it scale? So I'm assuming you're asking how does Prometheus scale, and the answer is it doesn't. Only scales vertically. So you can just make your machine beefier and beefier. And if you hit a wall, then you can scale horizontally by sharding. You can distribute your metrics across various. So you can say, yeah, all my application one metrics will go. My microphone changed. 1 second. All my application one metrics will go to my shard number 1, my application 2 metrics will go to shard number 2, application 3 metrics will go to shard number 3, like that. Unfortunately, Prometheus doesn't scale horizontally. What was your second question? Microservices. So yes and no. If you have 5 set of microservices, you can have a static configuration that works. Problem becomes not when you have microservices, but when you have ephemeral servers. When your servers go up and down a lot, this target file changes very quickly, right? How do you solve that is a different question, and there are a few ways to do it. Not API gateway, the push gateway is one, which means applications just push their metrics. No one scrapes it, like Prometheus doesn't scrape it. That's one. The second way is by using something called service discovery, which is nothing, which basically means you offload the target creation to some other process. There is a different process that's constantly tracking kaun se applications have come up, come down, and constantly updating these targets. Explain a little bit about sharding method. Sharding is it's a common thing. What does sharding mean? Sharding means कि आप अपने database को break कर दोगे. So if you have a very big app, for example, right now we were tracking /p metrics / let's say health check per metrics / to-dos per metrics. So what you can do is you can create a Prometheus server 1 and another Prometheus server 2. And this guy can scrape the user metrics. This guy can scrape the to-dos metrics. That way, if you have too many metrics, you can shard the database, or not the database, Prometheus, into shard where the metrics are going into different databases. Very common technique to scale when you hit a wall. For example, Notion also, back in a few years ago, they could not scale vertically. They use Postgres. Postgres also scales horizontally, but there is always a limit to how much data you can store in, let's say, 100 machines if they're replicating all the data. So they also sharded. They said, user 1, user 2, user 3, go to this database. User 4, user 5, user 6, go to this database, so on and so forth. So they have some 48 different running, all having disjoint data for different users. Sharding is a great way to scale, but also comes with some downsides. You will not see any of those downsides here. One downside might be it will be hard to aggregate data across different Prometheus instances. But very first principles thing, right? अगर बहुत ज़्यादा data होगा तो क्या करोगे? Data को आधा कर दोगे. Half of the data you store here, half of the data you store in a different machine. How does Prometheus capabilities are different from cloud providers like Azure or AWS? What extra thing does it provide? So it's open source. So it provides you self-hosting, which hosting you will, if you hit scale, you will not be charged more than what you're paying for your machines. Number 2, it has a lot of tools built on top of it. For example, Grafana is one of many tools built on top of Prometheus. So where a lot of people are innovating every day, versus in AWS, only 20 engineers are working on the monitoring dashboard of whatever AWS CloudWatch. So for that reason, mostly just pricing. And number 2, also extensibility. You can extend Prometheus a lot. There are a lot of open source tools built on top of Prometheus. That's not true for CloudWatch. How much resources will it take? Will it impact server performance where the metrics are being exposed? So metrics being exposed, not too much. So this is something we tracked. The metrics endpoint being exposed does nothing because it's just being scraped every 15 seconds, right? That's not a lot. It has maybe 1,000 rows, and 1,000 rows are being hit every 15 seconds by Prometheus. That's nothing. Problem becomes when you're tracking these very actively, right? अगर आप counter को increase कर ही जा रहे हो, you're increasing counters, you're observing histograms. How long does that take? Is that, for example, in a trading application, if you put Prometheus in a trading application, your latency will increase because you're increasing a counter, you're doing something. But again, that's not too much. Like increasing a counter doesn't take more than a few milliseconds, if not nanoseconds. So it doesn't affect performance, if at all. But yes, if you have a trading application where latency matters a lot, in that case, you will at least think twice. Should I monitor my application or should I not monitor? Or is there a different way to monitor? If setting a monitoring is this simple, companies pay for New Relic, then set up for this. Doesn't look. Setting up your own servers is also not that difficult, right? People still pay for cloud. So it's just convenience. That's just too easy, and this is also easy. But again, you have to maintain it. What if the server goes down? AWS CloudWatch will never go down. But your Grafana instance, if the developer leaves, you're screwed, right? So for that reason, the company might prefer AWS. In production, what would be the cost of running Prometheus, or people can run it locally and monitor? Interesting thought. And now that I think about it, you can actually run it locally. Prometheus is just scraping data, right? It doesn't have to exist on the internet. It should, but you can run Prometheus locally on your Mac and scrape api.hydexdevs.com and whatever a different endpoint that you have. Prometheus can run locally and still give you everything because Prometheus is never being exposed on the internet. It is pulling data from the internet. So you can actually run Prometheus locally, which means you have to pay zero for it as long as your machine is always up. If your machine sleeps or your electricity goes down, then you're screwed. For that reason, you might want to deploy it on the cloud. But you don't need to deploy Prometheus on the cloud. You can run it locally. It can scrape metrics from all, dunya bhar ke wo. Any side effect on server due to Prometheus, like can the server go down? So Prometheus will run on an independent server. It has nothing to do with your application server. Application server pe just you are exposing the metrics, which is just exposing another endpoint. Increasing a few metrics, exposing them on an endpoint. Prometheus is running on a separate server. So this cannot perform or affect the performance of this server. Of course, it is scraping this server every 15 seconds, but that's just one request every 15 seconds. That's nothing. Cool. For matches like IPL, what would you pick? I don't know. Depends on the developer, right? There's no good right or wrong answer here. There are trade-offs and good and bad things, sides of both the things. Like Grafana, you'll have to scale manually. For an IPL match, that might be problematic. CloudWatch will automatically scale. They're handling so many metrics for so many users. CloudWatch will get expensive. Prometheus will not get expensive. So pros and cons on both the sides. Cool. Grafana is done. Let's explore a bit of this Grafana UI and just get a little comfortable with it. We don't need to because in the end we'll use Grafana for the UI and not Prometheus. But abhi ke liye, let's just see ke data kya hai. Prometheus kya deta hai. We will not eventually use Prometheus for alerts or graphs. We will use Grafana. Let's quickly run a few queries here. Let's understand PromQL or Prometheus query language a little bit. Here are a few things you can track. For example, is the application running? It is. Am I running? Why is this down? This is up, but Grafana went down for some reason on my machine. Let me restart. $1990 था ना? Sorry, not Grafana, Prometheus. Oh, I changed. Oh, my bad. There we go. I changed the Prometheus.yaml and restarted it. Let me start. There we go. Cool. So this is the UI. And as I said, you can track anything here. What were our metrics? Let's look at them again. I'll have to hit a few endpoints for them to populate because I restarted the application. So let me hit user a few times and populate some data. And let me hit some random endpoints as well. /user/1. In the end, you'll actually see data when people use your application. I mean, so it just won't be the best data, but it's something. Cool. So let's look at the metrics. You can already track them here. It's not time series. It looks very ugly. That's the only difference. So what you can do is, if you want to track, let's say the total number of requests per route, which means basically this thing in a slightly more graphical fashion. So you can go to Prometheus UI. What is the name of the metric? HTTP requests total. You can query them. In this table view, it is showing you abhi tak 5 requests have gone here, 14 requests have gone here, 1 request has gone here. If you open the graph view, then you can see it in a more graphical fashion. You'll see it go up over time, so on and so forth. Ignore the data. This is the actual sort of new data over here. So let me, press the times, but you get the idea. It's hard to see this because पहले बहुत ज़्यादा था, बहुत कम हो गया है this number. So let me actually, do a complete fresh restart so that we have empty data. All right. /user. And now metrics endpoint looks like this. pretty digestible. We have seen this many times. Prometheus UI, if I try to do a HTTP total requests, yeah, there you go. 11 requests to slash user, a few to slash user, a few to metric. If I look at the graph, it's just started. So you don't see much right now. You get the idea, right? As you scale down, scale up, or let me decrease this time. So you can see, the graph a little bit. This is the total number of requests, which means it will constantly go up like this. And you are not interested in this usually. You also might be interested in the real total number of requests. Abhi it is कि this red graph is the total number of requests to slash user. This green graph is total number of requests to slash user with this status code, with this, whatever user application. The third one is the third one here. You might want total kitne requests आई, which means the sum of this and this and this. So the good thing is you can also add sum over here. That will give you the sum of all the requests. So you can play with these, PromQL attributes. Some we'll see a few more later. Rate, things like these. That will let you visualize data a little better. ये तो सबसे simplest है. Total number of requests over time constantly going up, will never go down. So if I keep refreshing, you will see this go up over time, increasingly. Is this a metric you want to track? Do you want to track total number of requests since eternity? If your application is running for 2 years, will you want to track a very long Sida graph, or would you want to track something else? The answer is you want to track something else. You don't want to track total number of requests. You want to track there's an example here, but you want to track the total number of requests per second. If you have a spike, the total number of requests per second will go up. If everyone is sleeping in India, the total number of requests per second will go down. You want to track the total number of requests per second. You don't want to track the net total number of requests. So what you can do is you can add rate over here. And I keep forgetting this. PromQL rate. There is a specific syntax to write it, which I'm forgetting right now. I thought this was right. See if we have it here. There you go. It was in the next slide. So what I was saying was, okay, we don't want to track this, the sum of total number of requests. Sure, you can do that, but it will be an ever increasing number. It will never go down. We want to track its rate, which is in the next slide. Prometheus also lets you visualize data as graphs. Total number of requests. So you already saw this constantly going up. Rate of total number of requests, which means number of requests over number of requests per second, basically, mota. How many requests are coming per second, which will go up and go down. If you have a spike, number of requests per second goes up. If everyone is sleeping in India, number of requests per second go down. So I think this was right. Only thing is, this sum shayad baad mein aayega. 5 minutes. Yeah. So it might be a little hard to read through this, but what does it say? The rate of total number of HTTP requests in a 5-minute window. Ye window wala part is a little hard to digest. What does that mean? We want the total number of requests per second, right? Maan lo, this is what the request cycle look like. We are scraping every 15 seconds. So let's say at 3 p.m., we had 5 as the total number of requests. At 3 p.m., 15 seconds, we had 8. At 3 p.m., 30 seconds, I had 10 requests. 45, I had 12 requests. And 3 p.m. or 3:01 p.m., I had, let's say, 13 requests. तो अब इस 1 minute में कितनी requests आई? How many requests came between 3 p.m. to 3:01 p.m.? The answer is 13 minus 5, which is 8. So how many requests per second do I have? 8 divided by 60, which is, some number, 0.02, let's say. So that's how you would calculate requests per second. But the question is, आपकी window कितनी बड़ी होनी चाहिए? Do I want to track everything from 3 to 301 and divide it by 60? Or do I want to track everything from 3 to 305 and divide it by 60 into 5? We want the total number of requests per second. बट क्या मैं उनको 5 मिनट के विंडो पे एग्रीगेट करूं या 1 मिनट के विंडो पे एग्रीगेट करूं या 30 सेकंड के विंडो पे एग्रीगेट करूं? Requests per second between 3 to 301, 301 to 302, 302 to 303, or requests per second between 3 to 305, 301 to 306, so on and so forth. So this 5-minute mark over here says कितने मिनट में आपको एग्रीगेट करनी है, रिक्वेस्ट्स को ऐड करना है एंड डिवाइडेड बाय 5 into 60 करना है, और डू यू वांट दिस नंबर टू बी एवरी 1 मिनट पे एग्रीगेट करो and see them. So this would depend on a few factors, like how granular of a data you depend on. अगर आप 1 मिनट करोगे और मान लो whatever at 3 p.m. IPL was supposed to start, so you will see a very big wick at 3 p.m. The request per second went huge. But if you have 5-minute windows, then it will not be as huge. Then between 3 and 305, there will be a smaller request per second count. So, in that case, you probably don't want an alert. If IPL has come, you've probably prepared for it. So requests per second should be a little more managed, and hence you can increase this window size. So this window size really depends on a bunch of trial and error. And it will change the final out, but not by too much. It depends on kitna aapko stagger kar dena hai. How less dramatic of spikes are you worried about? If you are worried about a spike very dramatically, then window ko chota kar do. अगर ऐसा है कि भाई अगर in a 15-minute window the request per second became huge, that means there's a problem. If in a 1-minute window request per second became huge, that's probably because someone posted a story and everyone clicked on it, right? So it's not a problem if it's normalized over 5 minutes. So this period sort of depends on you. And again, it's now showing you requests per second of 3 different types of requests. One request on /metrics, one on /user that returned a 200 status code, one on /user that returned a 304 status code. You can sort of sum it all up and see a single one, total number of requests, and notice eventually it goes down to this number. When we were playing with it, when I was hitting these endpoints again and again, it was sort of a big number, 0.14 requests per second. That means every 7 seconds I was sending a request. Slowly went down, and where did it normalize? 0.00606667. Why did it normalize at this number? Can anyone guess? I am not hitting it anymore. I am not hitting any of these endpoints anymore. So who is sending this 0.066 requests per second? How much? 0.067 requests per second means one request, itne requests in 1 second. So one request in how many seconds? 1 divided by 0.067. What is 1 divided by 0.067? It is 15. Wasn't our scrape interval 15? So what is this 0.067 requests per second? It is the /metrics request that Prometheus is sending. It should be ignored. There are ways to ignore the /metrics endpoint because वो तो Prometheus ही hit कर रहा होगा. But that is what this last request is. And as you can tell, it looks right. Every 1 second we're sending 0.067 requests, which basically means every 15 seconds we're sending one request, which is exactly true because Prometheus is scraping our /metrics endpoint every 15 seconds. So do we understand this? Do we understand simple graphs and rate wali graphs in Prometheus? There are 2 slides. There are more sort of graphs you can explore. All of them are here. For example, average time it took to handle our requests, even though average time is a little weird. You should do something else. We have buckets, percentile ek cheez hoti hai. We'll come to it when we reach grafana. But this is also a decentish metric to track. The total duration of request handling divided by the total number of requests. So if you look at the /metrics endpoint, along with the bucket, जो पूरी bucket है, इसके साथ हम 2 चीजें और स्टोर कर लेते हैं कि यार how much time, total time it took for requests to get handled, how many total requests have been handled. Total number of requests are 8. The number of requests that took less than 0.1 millisecond is 0. Number of requests that took less than 5 milliseconds is 8. Number of requests that took between 5 to 15 is 0. बट एक और चीज हम स्टोर कर लेते हैं when we are creating these buckets is total time कितना लगा है अभी तक, total request कितनी गई है अभी तक. So if you divide that, that's exactly the average request time that you have, right? Even though average is a bad metric, but you can track the average, which is exactly what you can do by HTTP request duration ms sum, which is this number right here, divided by HTTP request duration ms sum. You know, total number of requests कितनी थी divided by, उल्टा होना चाहिए ना, you get the idea, one of these two. Total time कितना लगा, हाँ नहीं, this is right. Total time it took to handle these requests divided by the total number of requests. So, you know, that's another graph you can create, so on and so forth. And then that's not graph, those are tables, but these are graphs that you can create. Most of the times you would be worried about this rate of change and not the total number of requests, total number of whatever, total time that it took. You will be worried about the requests per second, the average time per second, something like that. We'll reach there when we reach Grafana. But do we understand this? Let's do a poll. Do we understand how can you explore this Prometheus UI, see data in a raw format here, or see time series data in a graphical format like this? Yeah, simple enough. 92% is beautiful. So the next thing is Grafana. We do have time, so let's try to finish it as well. Prometheus is done. All right, let's do Grafana quick. Let's see how far we can reach. I think we should be able to finish it. But Grafana, observability at your scale, if you look at the landing page, it replaces the Prometheus UI wala part. Prometheus UI is decent. It has some downsides. Number one, it only works with Prometheus. Grafana works with a bunch of sources. It can work with Google Analytics also. It can work with Amazon ka data store also. It can work with Prometheus also. So if you have your data in 10 different places, Grafana might be an easier technology to create graphs on top of them. Prometheus UI works. One, it's not as pretty, it does not have as many features, but it only works with Prometheus. So if your time series data is only Prometheus, you can work with Prometheus UI. Grafana is a better choice if your data is fragmented across various sources. So even though you can use the Prometheus interface, Grafana makes your life a little bit easier. You can connect your Prometheus data to Grafana and you can visualize it better. So let's see how you do that. Step one is just starting Grafana locally, which is as simple as adding a third section to Docker Compose. We already have a Prometheus section. We already have a node app section. We can add a third section because Grafana को भी data यहाँ से लेना पड़ेगा. Grafana का data source would be Prometheus, and hence in Grafana we will have to specify कि यार please get all the data from here. So they also need to be connected via a Docker network. Unless they're running natively on my machine, अगर ये लोग Docker के अंदर run कर रहे हैं दोनों, to be able to talk to each other, they should be connected to via a network. Grafana will eventually be scraping from Prometheus, not scraping, but like getting data from Prometheus. We will specify Prometheus ka URL in Grafana, and hence, we're starting them all three in the same Docker Compose file. We are connecting all three of them by the same network called monitoring. Cool. So it's already started Docker Compose. If you have cloned the repository for today, it already had Grafana over here. So it was already starting Grafana. We weren't using it, but it was already starting Grafana on port 3001. Grafana by default starts on port 3000, but our application also starts on port 3000, which is why I've started Grafana on port 3001. So let me go to localhost 3001, and you'll see a login page. Let me put a username and password. By default, username is admin, and password also by default we have specified as admin, and hence if you give the username of admin and password of admin and login, it will ask you to change the password. Feel free to change it to whatever you want. I've just changed it to admin again, or you can skip it. And now you see another UI. So this is the third UI we're dealing with. We have the Node.js application. We have Prometheus. The third thing we are dealing with is Grafana. Grafana, if you open the sidebar, you'll see a bunch of things. Bookmarks, the dashboard, data that you've bookmarked, starred, the thing that you're interested in, you've starred. Abhi to we have no data. It's an empty Grafana dashboard. It has no data sources. It has no dashboards. So the first thing we have to do is add a new connection. Or you can also, add a new connection. And notice the places where Grafana can pull data from. The good part about Grafana is that, sure, it does help you visualize Prometheus data. it also lets you visualize Google Analytics data or Adobe Analytics data or whatever this is, Amazon Aurora data, so on and so forth. You can pull data from various sources or even AWS CloudWatch data. So let's select Prometheus here. What is our, so what did I do? I opened the left sidebar. I clicked on add a new connection. I searched for Prometheus here, selected Prometheus. And now you can click on add a new data source. It says data source added. Give your data source a name, let's say Prometheus-local. Give it a URL, Prometheus server URL. Now we have a Mac machine inside which I'm running 3 Docker containers. My Node app, Prometheus, and Grafana. These are 3 different Docker containers. Prometheus is exposed on port 9090. It is exposed on port 9090 of itself. Grafana is exposed on port 3000 and यहाँ पे port 3000 है. On our machine, it is exposed on port 3001. That's what the port mapping looks like. How can Grafana find Prometheus? Is it going to be localhost colon 3000? Sorry, 9090. No, right? There is nothing running on localhost colon 9090 over here. It needs to find it on the Prometheus container. And hence, what was the name of the Prometheus container? It was Prometheus. So what should the URL be here? Should it be http://localhost colon 9090? Or should it be Prometheus colon 9090? It should be the name of the other container, right? This name resolves to the IP of the other container. And hence, this is the right URL, even though it might seem counterintuitive. But abhi ke liye, this is the right URL. Eventually, when you deploy to production, then it will be something like prom.100xdevs.com. Abhi ke liye, it's just the name of the other container. Authentication methods. If you did add authentication, added a header over there, you can add those headers over here as well. As one of you pointed out, that endpoint should be protected. So you can protect that endpoint and add authentication over here. And that's it. Save and test. If everything is working right on your machine, you should see successfully queried Prometheus API, which means you're good to go. If you see an error over here, then this URL is incorrect basically. And you need to figure out what that URL is where Prometheus is running, or Prometheus is down for you. One of these things has happened. But if you're cloning the repo for today and you have started Docker Compose up like this, you're starting the Node.js application, Prometheus and Grafana, then Grafana can find Prometheus on Prometheus colon 9090. I saved it. This connection/data source has been added. So now I have one data source. As I said, we can add many data sources. We've just added the first one for today, which is Prometheus. We can pull data from Amazon CloudWatch, Google Analytics, so on and so forth. Next up, build dashboards on top of this data, right? That's exactly what we want. So click on build a dashboard, or you can go to the sidebar, dashboards, and create a new dashboard. Add a visualization to the dashboard. Select the source. Visualization kahan se aayegi? Where is this data coming from? Prometheus local, click on it. Now this is a little complicated of a UI to digest a few times. We have created a new dashboard. And in this new dashboard, I'm creating the very first visualization or very first panel. There are various types of visualizations you can create in Grafana. Time series are simple graphs that go up and down like this. Bar charts, a simple, very big stack. A gauge that will appear like this. Bar gauge, tables, pie charts, so on and so forth. Heat maps, histograms, simple text where you want to write something, some news that you want to buy. I don't know, too many things here. Time series is the most obvious one that we will use. The one that we saw on New Relic a lot, the one that we're going to use today is time series, which means we want to see the data in a time series fashion, go up and down. Yahan pe you can create your queries. Our data source is Prometheus local. You can write a PromQL query. You can click on code over here and write a PromQL query. Or you can click on builder over here and use a UI to do it. So either is fine. You can directly write the PromQL query just like we were doing over there. But Prometheus gives you this builder that makes it a little easy to create these visualizations. So what were our metrics? Let's Again, look at them. Localhost colon 3000 slash metrics. We have a few types. We have histograms. We have active requests, which is just a number that goes up and down. And we have HTTP total requests. Let's try to track the total requests per second maybe. Maybe let's track total requests first. Then we'll track total requests per second. Total requests will always go up. In fact, I think I have assignments on this only. So let's just look at them. If you go to the next slide, started locally, and then the next slide. Here are 5 assignments that, let's just follow them one by one. The first one is total number of requests to the slash metrics endpoint. So what metric do I want to track? I want to track HTTP total requests with the route set to slash metrics, which is 84 right now, but I want to see it over time. So select metric, HTTP requests total, HTTP requests total. With a label, the route should be slash metrics. This is what that query looks like. This is the query in the PromQL language, the query that we were running on Prometheus UI a while back. You can directly write the code like this, or you can use this builder to create the same thing. Both of them do the same thing. You can click on run queries, and you will see, it's a straight line going up because the metrics endpoint is being polled every 15 seconds. So that is why it's a straight line that's going up for the last 30 minutes or so. And that's it. You have created your first dashboard, your first visualization. You can click on save dashboard. I would give this a better name, something like number requests to slash metrics, save dashboard. Give this, dashboard or title, user app dashboard, or description if need be, and that's it. Now, I have a user app dashboard, where I have the very first visualization, which is the total number of requests to the slash metrics endpoint. That was the first assignment. The second assignment was the total number of requests to slash metrics per second. This isn't something you would ever be interested in the long run. This number will become huge. You'll see a very big line. It will be very hard to tell when there is a spike. Hence, let's add a new visualization. And this time, the metric is still the same. HTTP request total. The labels are also the same. I only want to track the route slash metrics. But notice, it gives you a hint also. Hint add rate. It is giving you a hint. Okay, you are probably not interested in the total count of this counter. You are probably interested in its rate. So, click on it and, it gives you something similar. We saw this a while back, right? When we were on Prometheus UI. Rate of a specific metric at a specific interval. Notice the interval here is $__ rate interval. I can replace this with 5 minutes or 10 minutes or whatever I want. But this rate interval default is just a default. It will pick based on kitna bada graph aapne khol rakha hai. If the graph is really big, it will make the interval also big. If the graph is really small, it will make the interval also small. So you can give it a constant interval, 5 minutes, 2 minutes, 1 minute, or you can just select this dynamic variable that Prometheus UI will decide eventually what it looks like. Click on run and notice, number of requests per second goes up to a certain peak and then goes down to again, the same number, 0.067. Then I hit it again a while back, then it went up a little bit, then it went down again. We don't have activity on our application. We haven't run it for 20 days. But if you do run it for 20 days, you will see it'll follow a pattern like this. People wake up in India, it goes up. People sleep, it goes down. That's the standard pattern you'll see in CPU usage also, number of requests per second also, so on and so forth. So let's call this slash metrics requests per second. Let's save the dashboard and then let's just explore it here. Now I have 2 sort of graphs that we're tracking. Total number of requests to the slash metrics endpoint, straight line up. Total number of requests per second to the slash metrics endpoint, which there are a few spikes, but generally it plateaus to 1 request every 15 seconds or 1 request, 0.067 requests per second. What is the third one? I'm assuming these are easy. Total number of requests to the slash user endpoint. Just have to replace the label. So add visualization. Total number of requests would be HTTP request total. Select label route slash user. Total number of requests to the slash user endpoint. It's not a straight line up this time. And also there are two different graphs. One is for the total number of requests that returned a 200 status code. One is for total number of requests that returned a 3 or 4 status code. Sometimes your browser caches these pages, and hence, when you see a cached value, you see a 3 or 4 status code. Otherwise, you see a 200 status code. So you see both of them. I might want to add, sum to it. So again, click on code and just replace this with the sum of this so that I don't see two different values. I see both the queries added together, irrespective of what status code returns back, if it's a 3 or 4 status code or if it's a whatever, 200 status code. That's the second graph or the third graph that you can create, and so on and so forth. You can create more graphs. Is that simple enough? Let's do a poll. Do we understand how you can add graphs? There's another interesting one here, a gauge that lets you see the total number of active requests, something like this. Very simple, take it as an assignment, or let me just do it really quickly. Add another visualization. So this is my user app dashboard. I will have to add visualization. Metric is the gauge. What was the gauge? The gauge was called active_requests. So click over here and no real filtering. There aren't no labels to filter on at all. But it's not a time series graph. I don't want to see the total number of active requests in a time series graph. I want to see it as a gauge, which means abhi number kya hai. I worry about how many active users are present right now on my website, not over a span of X, whatever, few months or few days. So you can select a stat wala type over here. It will give you something like this. The question really is, why do we have 4 active requests right now? I haven't hit this metrics endpoint anywhere. Prometheus is just hitting 1 metrics endpoint. That number should be 1. Why is it 4? There is some bug in our code base. That's not decreasing the gauge correctly. That is why the number is 4. But ideally, the number should only be 1. It should not be 4. But it is, which means there's some bug in our code base because we're not hitting the application right now. If 1,000 people are hitting the application, this number will go up and down. But right now, no one's hitting our application. This number being 4 means there is some issue or error in our Node.js backend. Cool. Do we understand these graphs? Let's do a poll now. Do we understand how to create graphs in Prometheus? Not Prometheus, Grafana. Great. Ish. Still decent. 87% is decent. 830. Very cool. Sorry, 930. The last thing is alerting, which is very simple. You have a bunch of these metrics that you're tracking now. For example, maybe this isn't a great metric, but these two are. Iska koi naam nahi diya maine, but I think, I forgot what this is. But this is the total number of requests per second to /metrics. Let's add another one, which is going to be the total number of requests per second, irrespective of if it's to /metrics or something else. So add visualization. What are we doing? The total number of requests without any labels and adding a rate to it. You might have to add a sum to it as well. So, this is the total number of requests per second with all 3 of these. I want all of them together. So I'll click on code. I'll add sum over here. That will add all 3 of these together. That's the total number of requests per second. Total number of requests per second. This one. Now I want to add an alert on this specific metric. Here, if the total number of requests per second exceeds 100 or 1,000, I want to be called, I want to receive an email, I want a Discord notification, I want a Telegram notification. So how can we add those alerts? There are a few ways. The simplest one is there is an alerting section here. So you can create alert rules. You can create a new alert rule for, whenever a threshold is hit on this metric, whatever, send an email, do a WhatsApp call, whatever. So let's give the alert a name. So what did I do? I opened the sidebar, clicked on alert rules, added a new alert rule. The name is going to be, high CPU usage. What is the metric that I'm tracking? The metric is HTTP requests total. I don't want a label. I want to add a rate, but I also want the sum. So I'll click on code over here. I'll add sum over here. Now I am tracking the sum of the rate of this specific metric. which is basically the total number of requests per second on a set interval that I haven't specified. I leave it to Prometheus to specify that. It's a Grafana managed rule slash alert. The threshold says input A. So यहाँ पे if you notice, it says this is the first metric A. I can add more metrics here. I can add another query that will be B, then C, then D. अभी के लिए I am just putting the alert on one thing called A. And the threshold, I've written whenever A is above, pick a number, 20 requests per second, 100 requests per second, 1000 requests per second, do something. So this threshold is what defines when the alert is hit. Let me keep it as 0 so that, the alert is hit immediately for us. Our request per second is really small right now, 0.067. I'm not hitting the application a lot. That's why I'm just setting it to 0 right now. So we can actually see the alert get triggered. Grafana lets sort of structure these alerts in folders and, recursive folders if need be. So let's create a new folder called, let's call it like backend alerts. Ki sari backend team ke alerts sare yahan pe. So, and if you want, you can add more labels as well. Ki, team, backend, and I don't know, manager, probably not the best thing. Let's do something else. Team, this thing, severity, critical, so on and so forth. You can add more labels to the specific alert. Evaluation behavior. What is the evaluation behavior? कि कितनी देर में अगर how the alert rule is evaluated. It might happen that your request per second reaches 1000 for 2 seconds and then goes down to 0. The on-call engineer shouldn't be woken up or usko call nahi jani chahiye if he's sleeping at his house. So it's a good idea to have an interval. Okay? If for 2 minutes this alert is hit, if for 2 minutes the request per second is more than 1000, only then trigger the alert. Otherwise, what will happen is it might be a fluke, a spike for whatever reason. You'll end up waking the on-call engineer, even though it was a very weird spike that happened for a second and then, normalized eventually. So feel free to set a smaller interval, but 1 to 5 minutes, whatever is your capacity. If the website is down for 5 minutes, it's fine. The on-call engineer shouldn't be woken up for 5 minutes. But if your, capacity there is lesser, if there is a spike, then, select a smaller number. So that's why you have to create an evaluation rule. I'm going to call it, small eval, which means, even if for a minute your alert is hit, you will send the call to the on-call engineer. You can have a bigger evaluation as well if for 5 minutes, for 30 minutes, so on and so forth. Last thing is configuring the notification. What should happen if the alert is hit? So this happens in a different section. By default, there is a contact point. We can add more in the future. A contact point is the Discord of all the backend engineers, the email of all the backend engineers, a different service like Slack, Telegram, PagerDuty. So contact point could be anything. कि कहाँ पे notification trigger होनी चाहिए. अभी के लिए we have selected the default one. Eventually we can add more. And that's it. I will click on whatever, save rule and exit. Unable to find dependent node B. Threshold should be on A. There is no variable B that I have right now. I only have one variable called A. And whenever A is above 0, I want the alert to be triggered. So to recap, I gave the alert a name. I defined my very first variable, the thing that I'm tracking on / alerting on, called A. I gave it this specific PromQL query to find what the value of A is at any given time. The sum of rate of HTTP total requests at this interval. That means all the requests ka sum, but not the current value, the rate, requests per second added, all of them. So if there are like 1, 2, 3 sort of request buckets that we have, तो इनको तीनों को ऐड करना है, but per second data को देखना है. I gave a threshold कि whenever A is above 0, throw an alert. I put it in a folder, gave it some labels, set evaluation behavior. If for 1 minute this alert is triggered, then send a notification to whoever. And then I configured the notification. I selected a contact point, which for now is just a default email that Grafana has. Eventually, we'll add more contact points here: the backend team, the frontend team, the DevOps team, the managers, so on and so forth. And I will create the alert. Now this alert is created. If I go to home / whatever alert rules, you'll see one of them is there. It hasn't yet been evaluated. Next evaluation is null over here, but as soon as it gets evaluated, it will throw an error because the threshold is 0. If the request per second is more than 0, the alert will trigger. And in our case, the request per second, even if I don't hit it at all, is 0.067 because the metrics endpoint is being hit. So you'll see this, go down very soon. And what I was saying was you can create more contact points. We have one default one, which is nothing. It sends a request to or an email to email@email.com. But you can add more contact points. For example, the backend team, which could have, harkirat@gmail.com and raman@gmail.com. Save contact point. You can select this other contact point to send the actual notification to. And there are various types of notifications that you can send. For example, SNS, if you want to just trigger notification there. Microsoft Teams, PagerDuty, Slack, Telegram, a webhook of your own, so on and so forth. So the contact point could be anything. Whenever the alert rule is triggered, which, for example, this one is triggered, it is pending right now, which means it is waiting for it. It's down right now, but it won't send the notification unless 2 minutes pass. As soon as 2 minutes passes, then it will send the final notification. Of course, it will not run locally because when I started Prometheus, I did not give it any SMTP credentials. Sorry, not Prometheus, Grafana. When I started Grafana, I did not give it my Gmail password basically, or some SMTP credentials. SMTP stands for Simple Mail Transfer Protocol. So अगर आपको कभी भी email send करना होता है, if you create a website where when the user signs up, you send them an email, or when they select forgot password, you send them an email, or when they do a transaction or an application, you send them an email, you get something called SMTP credentials from companies like Twilio, or AWS has something called SES or Simple Email Service, so on and so forth. Various places you can get it from. So you should put them here. If you actually want the email to be sent, you need some SMTP credentials. It will not send those right now. Webhook, you will be able to test, or other contact points you'll be able to test. And as you can see now, the alert is firing, which means the email should have been sent out. It will not because I haven't given any SMTP credentials here. But if I put my SMTP credentials, it will send an email to that specific user, or a Telegram message to that specific user, so on and so forth. Cool. I think that's it. One more good thing to look at would be visualizing histograms. We haven't really seen them. For example, let's do that, but let's just do a poll first, and we'll do that. We haven't yet visualized these buckets. What's the best way to visualize this? What will you worry about? Akirat, I will worry about the total number of people who have a response time of more than 1,000. That's a decent metric. If that number goes high, that means there's a problem. A lot of your users are seeing 1,000, 1 second plus response times. Another one metric might be how many people are seeing, let's say, less than 50 milliseconds of time. That's a good metric. What is the other metric you would track here? Let's get into that. But before that, baki sab samajh aa gaya? Do we understand how to create dashboards and alerts in Grafana? Let's do a poll. I will do a poll. Now there is a poll going. 83%. Cool. What can be the bug? Can you explore a little more? What bug? Sorry, where was the bug again? I'm just looking at Q&A right now. I'll answer Q&A for 5 minutes. Then I'll quickly show, or let me just show that. 84% is decent. Let me show one last thing, then I'll do Q&A, okay? What I was saying was, we haven't yet explored these, the histogram buckets. Let's try to visualize them. Let's create a new dashboard. Or we already have a dashboard. Let's add a new visualization here. Add visualization. Let's say one thing we want to track is the number of requests that took more than 3,000 milliseconds. How can I add that query? What do I want to track? The request duration millisecond bucket for, let's say, the /user endpoint, where the route is /user. If I run this, I see the total number of requests to the /user endpoint. Only, some of them, sorry, I see all the buckets. Okay. The number of requests, let me also add another label here where the status code is 200. Code is run query. So notice I see like all the buckets here. I don't see just the number of requests above 3,000. I see the number of requests that took less than 0.1 milliseconds, number of requests that took less than 100 milliseconds, number of requests that took less than 1,000 milliseconds, so on and so forth. Now, the question is what is a good metric to track here? average time it took for every request to get resolved. If the average goes up, that means there's a problem. That's a decent metric. Let's do that. Let's do that first. How do you track the average request per second or the average request time per second? We discussed this a while back. Whenever these buckets are created, along with these buckets, there are two more things or two more metrics that are stored. Total time कितना लगा इन सारी रिक्वेस्ट को हैंडल होने में 251. टोटल कितनी रिक्वेस्ट हमने हैंडल करी. How much time it took for all of these 113 requests to get handled. Of course, 4 requests took less than 0.1 seconds. 110 requests took between 0.1 and 5. We don't know how many took exactly 3 milliseconds, how many took exactly 4 milliseconds, but we know that 110 minus 4, that's 106 requests, took between 0.1 and 5. But we know there's some. We know that sum of total time taken by all of these 113 requests is 251. Total of number of cases 113. That means the average time is some 2.2 milliseconds, 2.3 milliseconds, right? So one thing we can track is Grafana. The A query / A metric is going to be HTTP request duration millisecond sum for, let's say, just one route with a specific 200 response status code. This number is, 2370. Correct. That is this right here, 23524, whatever that number is. There is status code 200 / user 200. Yeah, it's some 23,000 milliseconds is the total amount that we took to handle that request. And total हमने 19 requests handle करी हैं. So how can I visualize A divided by B? And the answer I think is, now I'm just doing it with you, plus query B, which is going to be basically this number. We got this number as a variable called A. We are getting this number as a variable called B. So I should pick up this thing. Label is route / user and status code is 200. If I run this, I will see A is this and B is this. A is some 23,000 and B is, what am I missing here? Code 200, HTTP request, some refresh. Method get route / user status 200 कहाँ है भाई? There you go. I've only sent one request that took 2-3 seconds. So let me, most of the requests returned a 304. So let me just do it for the 304 status code. Let me not do it for the 200 status code. Let me do it for the 304 status code, because most of the requests returned a 304 status code. If you look at it, 178 requests, sorry, user endpoint kahan hai? 19 requests returned a 304 status code, only one request returned a 200 status code. So let me track all the requests that returned a 304 status code on the /user endpoint. Or if need be, we can, also remove the status code completely, but then we'll see 4 lines over here. Tabhi maine status code dal diya abhi ke liye. We have A and we have B. We have total time it took for X number of requests. We have the number X ke kitni requests humne abhi tak bheji hai. Number 1, we want to see its rate. We want to see, no, I think that's fine. Yeah, we should probably see the rate, but this is also fine. Ideally, we should want to see the rate. Is window में कितनी requests आई? What was their total duration? What was their total time? And from this to this window, what is the total duration? What is the total time? So on and so forth. But let's say we take the cumulative number right now. We have A and we have B. We sort of want C, which is A divided by B. Now I want to see if you can do that. Can I do $A divided by $B here? Yeah, C, which looks right. I can see C, which is some 1238. That sounds right. 1238 milliseconds or 1.2 seconds is the average time that it took for my request to get handled. There is a warning here. Union. It's fine. ठीक है. So that might be one metric. This isn't in the end the main metric. The main metric is something else. If you want to track the average time it took for every request to get handled, you can sort of look at that. Even though this is a cumulative number, this is a bad number. This is okay. Since the beginning of our application 1 year ago till now, total time it took for all the requests divided by total number of requests that we have sent, let's say 1 million. That is this specific blue average that you see right now, C. The number C is the आज तक जितनी भी requests हुई हैं, let's say 1 million requests, what was the total time we took to handle those 1 million requests divided by what were the total number of requests. So very bad metric to sort of track. We should at the very least track this in windows. Okay, last 5 minutes mein, what is the total time we took to respond to all the requests? What is the total number of requests? Then in the next 5 minutes, what is the, we want to worry about the latest data, not the data since the last 1 year, right? So, you know, that is one thing you should change. But is average a good number? Have we discussed this before? Is average a good way to track data like this? The answer is no. Why? Because in average, there are outliers. Someone in Kenya might take 20 seconds for a request to get handled. That will increase your average by a lot. The same reason why you shouldn't look at averages in placements. If a college says, you know, our average placement is 15 LPA, that's because 2 people got 1 CR and, you know, rest of them got 3 LPA. Let's say the average still becomes 10 LPA. That's why average is a bad metric. What is a good metric? Median is a good metric. Or what did we discuss? Percentiles are a good metric. The general metric you want to track in monitoring, and very popular interview question is, you know, this only, what if there is an outlier? What would happen to the average in that case? And the answer is percentiles. You don't worry about all the users. You worry about only, let's say, the 99% of the best users. You don't worry about the worst 1% of the users. If the total number of requests that were sent to you are, let's say, 20 requests were sent to you, the first one took 1 millisecond, the second one took 1 millisecond, 2, 2, 2, 2, 3, 4, 4, 4, 5, 5, 100, 1000. 5, 5, 5. Let's say the 20 requests were sent to you, and you can clearly see there is just one outlier here, 1000. 19 requests. Ka average is just, let's say, 3. But 20 requests ka average becomes some obnoxious number like 40. Why? Because, you know, there's an outlier. One number is really big. So usually you worry about percentiles. What is percentile? क्या 90 percentile की performance कैसी थी? What did the worst person in the top 90% saw? If there are 20 people here, then you'll ignore the last 2. This is the 10%. Right? 20 people with 10% is 2, correct. So 90th percentile here is 5. The 95th percentile here is 5. The 100th percentile, of course, is 1000, but you don't worry about the 100th percentile usually. You worry about the 99 percentile or 95 percentile or 99.9th percentile. You don't worry about the 100th percentile. आखिरी बंदे को कैसी थी performance, you don't care. The best 95% of the people, उनका जो worst बंदा है, उसकी performance कैसी थी? The best 95% of the people, which is these 19 values over here, इनमें से जो worst बंदा है, how much did he saw? 5. So our 95th percentile is 5. And, you know, if that number is 5, it's great. Doesn't matter the last person had, 1000 milliseconds or 2000 milliseconds. If the 95th percentile is doing fine or the 99th percentile is doing fine, you will be fine as well. So the metric you want to track is not the average of the response times, which is what we had done here. What did we do here? We were tracking the average. This blue number is the average. It's not even the average. It's not the rate. It's not a localized average. It is like a global average. कि शुरू से लेके अब तक total time it took for all the requests divided by शुरू से लेके अब तक total number of requests. It's like a very bad average metric. So a slightly better metric is finding, localized averages. The even better metric is finding the percentile. Okay, in this window, what is the best percentile requests per second? In this window, what is the, if these are the response times, what is the 95th percentile see? 95th percentile को क्या time दिख रहा है? That is my metric. And if that is 200 milliseconds, that's bad. If that is 5 milliseconds, that is good. So how do you, given you have data in these buckets, आपके पास data ऐसे है कि 9 people saw 0.1 millisecond का time. 175 people saw 5 millisecond ka time. 178 people saw 15 millisecond ka time. What would the 95th percentile be here? 95th percentile would probably be the best 170 people or 165 people. So unke liye it will be some average of, let's say weighted average of 0.1 and 5. So some number very close to 5 milliseconds. What is the 99.9th percentile here? It will probably be 15. The worst person is seeing, 15 or, some average of 15 and 5 and some weighted average of these three. So the way to find percentile or, the metric to obsess over is given these buckets, what is the 95th percentile seeing? जो 95th percent पे बंदा बैठा है उसको क्या टाइम दिख रहा है? 99th percent पे बंदा बैठा है. The amongst the best request times, the 95% of the best request times, what is the worst person seeing? Which means 95% of your users में सबसे गंदे बंदे को क्या दिख रहा है? आखिरी के 5% को जाने दो. The last 5%, let them be. They're seeing a bad performance, that's fine. 95% में the worst banda, what are they seeing? That's what the 95th percentile is. So if you want to track that over here, how do you do that? Let's try it. Let's create a new dashboard or new visualization. Let's select the bucket over here. Let's say, HTTP request millisecond bucket. We can filter it down even more, method get, route metrics, whatever. So let's do that. Method or route is /user and status code is 304 because that was the more frequent one. If I run just this, I see all the buckets. कि हाँ भाई इतने लोगों को 3 seconds से कम लगा, more than 3 seconds or whatever, more than 5 seconds, more than 1 second. Oh, sorry, less than infinity time, less than 1 second, less than 500 seconds, less than so on and so forth. All of these buckets I can see over here. Now I want the 95th percentile. Notice it gives you a hint over here. Add histogram quantile. Quantile in Prometheus is not Prometheus, grafana is the same thing as percentile. So percentile is called quantile in grafana. If you click on this, it number one finds the rate. So it will find the local average or percentile. Number two, it adds all of these 5 rows up. Okay, we don't worry about one of them, we worry about all of them. And then it adds the percentile. Okay, what percentile are you worried about? 99th percentile, 95th percentile, so on and so forth. So, usually you worry about 99th or the 95th percentile. So let's say we worry about the 95th percentile. Run query. Now it is giving you, that's very hard to see it over here. It's giving you the 95th percentile during that duration. It goes down to 0 because we haven't really been sending requests to the /user endpoint. Let's replace this with the /metrics endpoint. Because we haven't sent too many requests to the /user endpoint. So replace this with /metrics and run it. And now it will give you what the 95th percentile is seeing on the /metrics endpoint, which again is very hard to see as over here. It would make more sense if we had a more whatever used application, but यहाँ पे you can see 4.7 से लेके 13.5 तक जा रही है over time. The 95th percentile, what they are seeing. If I change this to 99, will this number go up or will this number go down? If I'm increasing the number of users, I'm adding more gande users. So of course this number will go up, right? 95th percentile mein the worst that the people are seeing is whatever 13.5 as the response time. 99th percentile mein the worst that the people are seeing is 14.7, a little bit more. 99.9 percentile mein it will be a little bit more. So this is the number that you usually track on histograms. Basically this is the query / graph that you worry about whenever you're using histograms or this data right here. We did not really visualize this data abhi tak, and the way we have visualized it is के इसमें से 95th percentile निकालो कहाँ lie कर रही है. Is it lying over here? Is it lying over here? Is it lying over here? Where does the 95th percentile lie? And that is the person that I worry about. उसको कितना गंदा time दिख रहा है उसके basis पे I'll throw an alert. If the 95th percentile is seeing 20 seconds of response times, that means it's bad. If they're saying 20 milliseconds of response time, that means it's good. Cool. Let's do a poll. Did we understand histograms, percentiles? This very complex query to look at, but hopefully easier query to build, which gives you, if I save this dashboard, let me give it a name. 99 percentile response time on /metrics. save. And if I go back here, this is the metric that I just added, which is the 99th percentile of response times. कि जो metrics endpoint जब hit हो रहा है, तो अगर 100 बंदों ने hit किया, उनमें से top 99 को सबसे गंदा टाइम क्या दिखा? I repeat, if 100 people hit the slash metrics endpoint, what did the top 99 people see? What did the worst person in the top 99% people saw? That is the time that we're tracking over here, which is, anywhere between some 4.95 to 14.7. That's it. Cool. Anything else? No, that's it. Let's do a poll. Did we understand? To recap, today we recapped Grafana a little bit. Sorry, Prometheus a little bit. Monitoring. Oh, beautiful. People understand. Great. Goes up and down. Now it's at 83%. I'll do Q&A after this. The class is officially done, so feel free to drop off if you understand everything, which 84% seem to. To recap, revised monitoring, discuss the architecture of Prometheus one more time, understood how can you add raw metrics without Prometheus, without Grafana. Then we added Prometheus, understood counters, gauges, and histograms. Final code, this is what we did last week. Abhi ke liye, this week, we actually started Prometheus. We ran some Prometheus in Prometheus. We ran some queries in Prometheus UI. We created graphs in Prometheus UI. We saw it wasn't the best place to create graphs. We started Grafana. Grafana maybe installed a bunch of graphs. We understood how can you create dashboards. And then we understood how can we add alerting. There are a bunch of examples / assignments here in the Grafana and the Prometheus UI part. The only thing that's not covered in the slides is the thing that I covered in the end, which is how can you visualize percentiles when it comes to buckets of data or histograms of data. Okay? Cool. We'll end it there. I'll do a Q&A after this. So I'm looking at chat now. Any specific questions for today or otherwise? Notion docs, extreme max, a lot of Notion docs. A lot of them seem repeated. Cool. Yeah, audio getting. That seems like an interesting thingy to try. Is there a password? Username password. Doki. Start interview. Oh wow. Okay. Start audio interview. Hello. 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 Didi is not responding. Sam Altman is not responding. Decentish platform, though, like not the best execution, like UI wise or chal nahi raha hai, but idea is actually pretty solid. If you've heard of Mercor, it does something very similar. And their interview, if you've taken, it's actually really good. वो actually डर लग जाता है, when you're giving the interview, if you don't know an answer, you actually feel scared. And yeah, so you're not. It seems like what you're doing is converting voice to text directly in the browser, sending text to an LLM, getting the response, and then converting text to speech. Is that correct? There are better ways of doing this, but expensive ones. This one's probably cheap. The expensive approach is just APIs. So OpenAI has what's it called? An API called real-time API. I tried it for a few hours and had to pay not a few hours, like a few minutes, and some $5 ka bill ban gaya tha. It's expensive, but much more easier as a developer to write. And also much more, the responses are much more human. It understands when you're interrupting it, so on and so forth. In your think, book written in Java, thought he hated Java. Could have sworn I saw someone. So I saw this somewhere. Someone had built an application. Could have sworn they built this interpreter in Rust. Haven't looked at the book. Just put it there. Why is Excel seeing everywhere? It's just very popular especially in real time communications. For example, WhatsApp uses it, and Discord uses it. Other than that, it's just over engineering if some companies are using it. But yeah, it definitely is popular. And just say there's a lot of cult in Rust. There's a lot of cult in Elixir as well. Not yet. Is keeping the ETH a problem? No, not really. Honestly, Sol is where most of the projects will be built, or most of the jobs, or call it grants, will be given. So I would generally, ETH is very inactive right now. Abhi to sab kuch is inactive. If you compare the both in terms of the fees that they're making, the DEX fees, everything, there's more activity on Solana. Convert to bytes, send. Oh, sorry. Can you talk about audio can be transferred over WebSockets? So what is audio? In the end, so maybe a simpler example is what is video. Video is just a bunch of images, right? You would expect it's 30 FPS of images. It's just 30 images in 1 second that you have to stream. So can you convert an image to base 64, send it via WebSockets at 30 FPS? Sure, you can. Audio is similar. Chalo, before that, video, as I said, 30 frames per second, convert them to base 64, send them. But is that the optimal way? No. Why? Because videos, if videos MP4 files were stored in nothing but a bunch of images, then imagine the amount of images that would be a lot. So videos as well as audios have something called codecs. You might have heard of H264, AV1, H265, compression algorithms. So whenever you are streaming video via MP4 HLS, you are not really getting back a bunch of images. You are getting back some data that is encoded using, let's say, an algorithm called H264, and is being decoded by a browser using the same algorithm. So the way you would want to send audio or video is to actually encode the audio using some of these algorithms. For audio, forgetting the name now. Just said .wav files बनती हैं. I'm forgetting the name of that specific encoding algorithm. Audio का कौन सा होता है? दो ही होते हैं famous ones. I'm forgetting the name of both of them. But long story short, you will have to write the algorithm to encode the audio and send it over the wire through WebSockets, which is sort of hard. You have to understand how encoding and decoding of video and audio works, which is why you should prefer WebRTC rather than WebSockets, because if you use WebRTC, it will take care of encoding and decoding your audio. It's just forwarding some packets that's already encoded. So that is something you don't have to worry about. That is why I would prefer using WebRTC over WebSockets here. Can you do it? Yes. How can you do it? You'll have to worry a little about, or understand a little how audio encoding works, and send those bytes over for both encoding and decoding. Okay, done. What else? I think I saw that. Give me funding so I can deploy it and buy a domain. Oh my cool. So let's just see if it works or not first. And oh, oops, daisy. Okie dokie. So create a room. Create. Okay. Add a song to queue. I'm hoping / assuming I can. I don't know. Oh, chat is there. Very cool. Oh, it's a YouTube URL. Alrighty. So let's add a quick song over here. Add to queue. Okay, this one's here. How do I play it? Start streaming now. That's pretty cool. So now let's add a different one. Let's say this one. Add to queue. It'll slow the website for some reason, but okay. Let's add a third one. Let me just add the same one again. And again, alrighty. Now the question is, I can search directly. Oh, there you go. I don't know. Dance. Add to queue. Alrighty. Now the question is, how do people see it? So I'm assuming like this. People can come here. So they have to sign in as well, and they have to upvote. Allow me to add a song. How can I allow you to add a song? Button. What button? Oh, users are allowed to enter song. There you go. Okay, can you add a song? Can you upvote it? Okay, there you go. Oh, there you go. We added a song. Now the question is how, okay, there you go. Next. Yeah, this is pretty clean. Good implementation. Slightly less confusing than what the other guy made. And what did you want? How much money do you want for the domain? I'm happy to transfer. Put your UPI here. Unless you're buying some 1 lakh ka domain. I can transfer. Just put your UPI here. It's a good one. I would actually like to try it in an application. All right, cool. WhatsApp me, but good implementation. Yeah. All right. I hope two things when you're in your Docker file video when building Nexus application, you pass it as URL during build because static is better. Correct. That is correct. Use the build arc for database, but not security pass. That is correct. If it is a public image, then your database URL would be caught, or people can inspect through it and see it. So what's your thing using Docker secrets? Cool. We should read that and put it there. If there seems like there's a doc. Yeah, that's the most ad hoc first approach that I saw. And believe it or not, we had a public Docker image back then. And Sargam found, the build arg was there and told me he also wanted to $50 bounty for that. But exact problem that you're specifying, sort of we saw in production. And yeah, this seems like something to discuss in the class. But yes, if you have a public repo, you'll get caught. What is the other thing? Cool. I'll also look at this. Let's see. Type to secret. Got it. So you create a separate file and you mount that secret over here. It's never present in the Docker image. What else is this? I was working on a network and the other thing we can connect two containers without explicitly creating a network. You can see all right, I'll look at this. You can connect two containers without. That's good. What is the point? Two containers with Postgres container app container. We can the network specifically, but instead the host names, we have to use the container IPs in Docker whenever you run. That is true. They are connected by the default bridge. But how do you? Acha, okay. So we can run Docker inspect container image thing. Yeah, my question was how do you get the IP? We can get the IP of the container and we can make sense. But isn't that a little hard? I mean, makes sense. That works. But networking makes it a little easier to identify it through the name. But yeah, what you're saying is correct. Anything else you have? Interesting knowledge bites here. I can bring them on WebRTC. Media Soup is very obsolete now. If anything, I'll bring it on Pion or LiveKit. Media Soup is like not maintained as well as much these days. My question I meant was there a separate data account created for every user who's interacted with the program account? So yes and no. If the user wants, they can use someone else's account. If the user wants, they can give their own counter account. And where exactly is it stored? In Ethereum contract address is stored everything. Yes. So in Ethereum, the contract address stores everything. In Solana, all the data that you're storing is a different account on the Solana blockchain. Just like I have one account here or multiple accounts here in my backpack, you can create similar addresses. So if you have a website which has 1 million users, you actually have 1 million addresses, one for every user on your website. It's a little counterintuitive, but just that is how the Solana blockchain works. Is all the data stored on the validator's local disk? So yes and no. It is stored on the disk. It is also it's persisted on in memory. Also, it's persisted on the disk. Also, every validator changes in the leader schedule. That is correct. Then how is the data persisted across period of time? Validator like leader. That's true for Bitcoin also and Ethereum also, right? There is only one validator that proposes the transaction, but all the other validators also run the transaction. So the state change happens everywhere. All of them will persist the change, not just the leader. Can HLS be used to stream video from front end to back end? So the answer is no. So what is HLS? It's like an MP4 file. It's nothing else. HLS is nothing but just like there's an MP4 file you can use to run video. HLS is similar. It's just a bunch of files. So can you serve files from a front end to a back end? If I today say create a website ka front end that a backend can connect to, how can a backend initiate a request to a front end? It can't, right? Front ends are not you get the idea. Front end is running on a user's browser which doesn't have a public IP. So the answer is no, basically. you can find weird ways around it. Like the problem statement is smaller. Can a backend ever visit a front end and get some data from there? And the answer generally is no. You can create tunnels, a bunch of things you can do. But generally the answer is no. It can be served from a backend to a front end. It cannot be served from a front end to a backend. Yeah, that was more of a web-based version. People actually saw I'll create Premiere Pro, but I was just thinking of creating a web-based video editor, something like InVideo. Normal page length, 6 to 8. I think that's bad. 6 to 8 is good. New but small. They haven't merged any PRs. So by any chance, yes, that is a good org to have. जहाँ पे ज़्यादा PRs नहीं है and नहीं है. Workshop, I have not attended it sorry, I haven't thought of it too much. Most probably it will be WebRTC, decentralized WebRTC using DPIN. There's a company called Huddle. We'll try to build something like that. Bonk bought video offline. Oh yes, I have a stack of offline videos I have to put. That being one of them. Done. How are there 4 Notion docs but like 50 messages in the chat? That's not cool. Well, someone exactly like the problem that they've proposed is also the problem that Prisma provides, which is cool. Cool. That is all I had for today. What will we do tomorrow? I thought we might not be able to reach Grafana today. So I was thinking of doing Grafana tomorrow. I have no thoughts. Let's look at the syllabus. We have to start Kubernetes, but I just want to hash out other things before we reach there. So let's see. DevOps, Linux is like an offline video I can add. VMs are done. ASGs are done. Containerization is done. ECS is done. Kubernetes, IAC, Terraform, monitoring is done. Package management, CI/CD is done. GitOps, CDN, and object stores. Oh, I think we might be starting with Kubernetes tomorrow, guys. I don't see any other, major topic left or minor topic either. I don't know. We might then also take a break. I don't want to start Kubernetes mid of week. So we'll see. But then if not tomorrow, we'll start. Music guy want to see load. He in doubt. Check it. Sorry, I don't know what he means. Q&A. Clientless, serverless. Oh, we can do serverless. Beautiful. Yeah, let's do serverless tomorrow. Someone said client side. Clientless. Okay, let's do serverless tomorrow, and then we'll go from there. Bunch of Notion docs. Another Zoom meeting. What is the easiest way for me to stream video from front end? I don't think you can do that, as I said. All right, cool. We'll call it here. Thank you, guys. Have a good night.